So now we're going to talk about probably one of the most important and common ways of modeling quantitative data, and this is referred to as the histogram. And this is going to be key whenever we're going to be moving into later parts of statistics, because this is where we're going to be first introducing the concept of a shape of a distribution and what that looks like. So in order to get to that point, we need to know how to actually make a histogram. So to make one, we have a set of quantitative data here. We have a set of just numbers. And we're going to make, first decision on this is we're going to make what's called a bin width. When you're making a histogram, you need to decide what kind of bin do you want to make to fit certain groups of data. Now, all of these numbers are pretty close together, so you never really want to use a bin with 1. That's almost effectively useless. So you want to stick with a number. 2 is fine, that's what I'm going to use in this case, but if these numbers were bigger, you might want to do 10s, 5s. Usually good round whole numbers are a good place to go, something easy to count by. So the first thing you want to do when you're starting a histogram is you want to go ahead and make your axis that you're going to work with here. So the key to a histogram on the bottom is the actual number. These are the numbers that we have in our data. So I'm going to go ahead and call this axis down here the data. Over here is what we call the frequency, or the freak as it's sometimes written, F-R-E-Q. This is where we actually have the number of things that are going to fall into each bin. So as I mentioned, I'm going to be using a bin width of 2. So what I'm going to go ahead and do is at the beginning of this, we start at 0. Then I'm going to go a little bit of a distance, and I'm going to go to 2. Then I'm going to go a little bit more, and we're going to go to 4. And then I'm going to go a little bit more, and we're going to go to 6. And I'm going to go a little bit more, and then we're going to go to 8. I'm going to go a little bit more here, then we're going to go to 10. I'm going to go a little bit more, we're going to go to 12. A little bit more, we're going to go to 14. And then I am going to stop at 16. So counting by 2s all the way up to 16. So now what we do is we go ahead and we take a look at our information. Now this first bin, what you do is you're going to find all the numbers between 0 and 2, not including the upper bound. So not including 2 itself. And you're going to make this bar that we're about to make as tall as that. So over here on this side, what I'm going to do is I'm going to start and I'm going to count. Usually your frequency is fine to count by 1s. Very, very, infrequently would you ever end up with a case where your frequency extends beyond that in small data sets like this. So I just count by 1s up to 3, 4, 5, and then 6, and then 7. That should suffice. We might want to end up going up to about 8, and then perhaps 9, but we should be able to cover everything in here. So starting with the first bin, when I look up here at my data set, I'm going to count the numbers that fall in between 0 and 2, not including 2. So that's 1, 2, 3, 4, 5. So we have 5 numbers. This is these 1s, this is and the 0 here. So we have 5 of those. So we make the bar and we go all the way up to 5, and I go ahead and drop this bar right down and try to make this as straight as possible on top of the 2. So the next one is to go from 2 to 4. So 2 to 4, that means we're going to find all numbers from 2, including 2, everything in between 2 and 4, but not including 4. So that means 2 and 3s, basically. So here's 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. So I do need to come a little bit higher up here on top of that. So we'll just go all the way up to the top of 10 up there. We'll come right back around and we'll come back down to the bottom. So this bar will represent the 2 to 4 range. So the next one we're going to want to do is we're going to want to get all the numbers in between 4 and 6. So that means all the numbers including 4 and 5, but not including the upper bound of 6. So we don't have any 6s in our data set. So we're going to just count the 4, and I believe there's 1 5. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. So we're going to go ahead and we come straight across and make sure these bars touch as long as their bins touch. So we come straight down to the 8. And just kind of eyeball about how tall it should be. You don't have to be perfect with it. But there is the bar that will represent the 4 to 6 bin. So now is when things get a little interesting. We don't have anything in between 6 and 8. We don't have anything between 8 and 10. We don't have anything between 10 and 12. We don't have anything until we get out here to the end. So what do we do with this space? We just leave it blank. That happens often, and it's going to be important for later parts when we talk about this concept called outliers, which are coming soon. So the first thing is I have a 13. It's one of the only numbers we haven't used up here. 13 falls in between 12 and 14, so that means that there is 1 that falls in between here. So we just kind of go up to the 1, and as you get a little bit farther away, it's a little bit harder to kind of keep track of how tall they should be. So just do your best to try to line it up. And then, of course, between 14 and 16, that's where we have the 14 here. So we go ahead and have another 1 that's 1 high. So here is a histogram. So from this, we can start to make some real assumptions about what kind of distribution this is, and we can also start describing it, which is going to be important when we move into later parts.